So in this video, we're going to be looking at an overview of some definitions that we will use later on in this chapter regarding probabilities. So you can see that quick little history lesson there. I'm not going to read it to you, but some big definitions. Probability is just a ratio that's expressed as fractions, decimals, or percents, and it's considered by the what you want to happen over the total number of possible outcomes. So with that being said, the experiment is how you're going to find the probability. So experiment is just an activity that you can observe and record. So some examples that I added into your notes: drawing a car, drawing a marble out of a bag, drawing a sock from a drawer, winning $5 on a scratch-off ticket, winning the lottery, anything that you could do multiple times and record the desirable event, winning $5, versus the undesirable event, winning $0 or not winning $5. And so then the outcome is going to be each of the possible result of an experiment. So we've got two spinners, spinner A and B, and we're going to look at the outcomes of both of those. The outcome is truly just listing off all the possible things that could happen. So before we look at our spinners, let's think about a very simple example of flipping a coin. So the question says, what are the two possible outcomes of flipping a coin? And then we're always going to assume that a coin cannot land on the edge. So if I flip any standard coin, my possible outcome is either going to be I'll flip a head or I'll flip a tail. And so the outcomes of that are a head or a tail. You'll notice I have those little curly brackets around it. That's just because the outcome we're going to see in just a second is going to be our sample space. Now, of these two spinners, what are the possible outcomes? Before we get to the spinners, what are the possible outcomes of tossing a six-sided die? So the thing that you would play with Yahtzee or any board game. So the possible outcomes, what could your die land on? It could land on a 1, a 2, a 3, 4, 5, 6. Or if you wanted to get fancy, you could do them in their actual format that you would see it on the die. But I'm fine with just listing off the numbers themselves. Now, what I've been alluding to, the possible outcomes for the following spinners. And so for spinner A, I have the number 0 all the way to 9. So my possible outcomes are going to be 0, 1, 2, all the way to 9. Spinner B, it only has two possible outcomes, red or blue. Now, with that same idea of that same idea of outcomes, we have this thing called the sample space. The sample space and the outcomes are really the same thing. They are the set, which just means we're going to put the curly brackets around it, of all the possible outcomes. And so what is the sample space for the spinner? Well, that's going to be that same thing, 0 to 9. And then the sample space for the other spinner, red and blue. So the big thing with sample space and outcome, they're pretty much the same thing in our context. As you get higher in probability, that's not always true. But in the sake of this class and your context, they will be. The big thing, though, with sample space is this part right here, that it has to have those curly brackets around it because it is a set. A set just means that it's a group of items, numbers, letters, whatever the case. And then my last thing says list one outcome from each of the spinner. So now I'm not listing all the outcomes. I'm not listing the sample space. I'm just listing one outcome. And so truly you could list any of these. I'm going to pick the number 6 from spinner A. Spinner B, you could not pick orange because that's not something I could select from my spinner. However, you could pick either red or blue. And so I'm just going to pick red because it only asks for one possible outcome. The only thing, or not the only thing, but one thing I could not put on my spinner on the left, I could not say that an outcome for that is 13 because there's no way that my spinner could land on a 13. It is not an outcome. So some more definitions. We've got tree diagram. So tree diagram is going to be just a visual representation of the sample space. It's a model. So I've got a tree diagram there for tossing a coin. Heads or tails would be the possible outcomes. Let's look at a little bit more complex and look at tossing 2 coins and rolling a colored die. Now, we're going to look a lot more at our multi-step experiments in 9.2. However, right now we're just kind of looking at this idea of a tree diagram. So my first toss is modeled in this first column. In my first toss of a coin, I can either toss a head or a tail. And so that's really the only things that can happen when I toss one coin. So first coin. My second coin could either be a heads or tails, but I could get a heads from the first head, so I could toss 2 heads. I could toss a head or a tail. I could toss the first coin as a tail, second coin's a head. First coin is a tail, second coin's a tail. And then in this last column, I have the die that I'm going to also roll, red, yellow, or blue. And so coming off of each of those scenarios, I'm going to have the possibility of red, yellow, or blue. And so we're going to actually be making tree diagrams later on in these notes. This is just kind of giving you an intro to what tree diagrams look like and how they could kind of appear in experiments. But we're going to see them later on. We're going to actually draw several of our own tree diagrams. And then another definition, we've got this term event. Event is any subset of this sample space. So my sample space may be rolling a die, 1, 2, 3, 4, 5, or 6. My event may be, okay, well, how many even numbers could you roll? Well, that event would be 2, 4, or 6. So an event is a very specific example of the broad sample space. So an experiment consists of selecting the last digits of a phone number from a list of numbers in a friend's contact. What is this sample space? And so what I'm looking at, I've got a phone number. We're not going to include the area code. I've got a phone number, and I'm looking at that very last digit is what I'm focusing in on for my experiment. Part 1 says to list off the sample space. Well, the sample space is what are all the possible digits that could be in that last digit? What are all the possible numbers? Well, I could have a 0, 1, 2, 3, 4, all the way to 9. Can't have a 10 because that would be wouldn't fit in the last digit. And then event A consists of the outcomes where the last digit is less than 5. So event A is going to equal the numbers less than 5. 0, 1, 2, 3, or 4. Can't include 5 because it has to include the numbers less than 5, not less than or equal to 5. And so there's my event A. Event B is going to consist of outcomes whose last digit is odd. So my odd numbers are going to be 1, 3, 5, 7, 9. And then event C is going to consist of the outcomes where the last digit is not 2. So it can be anything else, it just cannot be 2. So it can be 0, 1, not 2, 3, 4, 5, 6, 7, all the way to 9. You may want to make a note to yourself that it really includes everything except the number 2. No 2.